Moving on to lesson 5.6, part 2. Solving absolute value inequalities. When solving absolute value inequalities, you're going to follow a series of steps. We're going to write out those steps and then go through some examples. Step 1, isolate the absolute value symbols. Just like you do when you're solving an absolute value equation, you're going to isolate the absolute value symbols just like you do when you're solving an absolute value equation. It goes through the same process. Step 2, set up two inequalities. Drop the symbols, the absolute value symbols. Keep one the same, and then flip the inequality sign and flip the sign of the number. And that will make a whole lot more sense when we go through some examples. Step 3, solve each one. And step 4 is decide if it's an and or an or. Okay, this is very important. And you go off of the original when you're doing this. If it's less than or equal to, it's going to be and. If it's greater than or equal to, it's going to be or. Let's go ahead and go through some examples here. Example 1 says solve and graph the absolute value of A is less than 3. Step 1, isolate the absolute value symbols. Well, nothing's being added or multiplied or divided to the absolute value symbols in this case, so I'm good to move on to the next step. Step 2, set up two inequalities. So I drop my absolute value symbols, and I set up the first one as exactly as it is. So A is less than 3. My second one, not only do I flip the sign of the inequality, I also flip the sign of the number as well. Okay, so I'm flipping both the sign of the inequality and the sign of the number as well. Then step 3 is to solve each one. These are already actually solved though. Step 4 is to decide if it's going to be an and or an or statement. And you can kind of do this by just looking at it, okay? It says A is less than 3, so I would go to 3, I would have an open circle at 3, and I'd be going this way. And then it says A is greater than -3, so I'd have open circle, and it looks like they're going to meet in the middle. Therefore, this is going to be an and. But you can also go ahead and go off of the symbol of the original inequality. If the original inequality is less than or equal to, it's going to be an and graph. If it's greater than or equal to, it's going to be an or. But again, you can also kind of tell based on the result of your two inequalities that you got. Let's go ahead and move on to example number 3. It says solve and graph. Well, step 1 is to isolate the absolute value symbols, which step 1 looks like is done. The absolute value symbols are isolated. Nothing is being multiplied or added or divided or subtracted on the outside of those symbols. Step 2, set up our two different inequalities. So the first one will be 2x minus 2 is greater than or equal to 4. Remember, the first one is always going to be the exact same. The second one, you're going to write the first part the same, flip the sign of the inequality, and flip the sign of that resulting number as well. Okay, now let's solve both the inequalities. Add 2, 2x is greater than or equal to 6. Divide by 2. X is greater than or equal to 3. Then here, add 2, add 2. 2x is less than or equal to negative 2. Divide by 2, divide by 2. X is less than or equal to negative 1. So now we have to decide, we have to graph them, but let's decide if it's going to be an and or an or statement. Remember, if it starts as less than or equal to, it's and. If it's greater than or equal to, it's going to be or. And you go off of the original when you're deciding that. So my original says greater than or equal to, so it's going to be an or statement. So we graph x is greater than or equal to 3. So solid dot on 3 going this way. And x is less than or equal to negative 1. Solid on here going this way.